Routers are classless devices. They don't think, generally speaking, that we're using an address space classfully. And this is a good illustration of that fact. 172.16. Well, what class of address is that, and how, by default, would that work out? Well, 172.16 is a Class B address, and the default mask would be a /16 mask, because classfully, based on Class B, we would have a 16-bit mask. Now, if we look at this topology, we could not get away without having subnet masks redefine the network space. I want you to see this. We've got a router, and it is straddling two different IP subnetworks, 172.16.2 and 172.16.3. Now let's say we chose to use a /16 mask. You couldn't do this if that were the case. Why? Because you can't have two different router interfaces both going to 172.16. The router won't allow it. The router would not allow it. Every router interface, every logical router interface on this single router would go to a different IP network or subnetwork. Okay? So in order to address two interfaces, you would have to put those two in different IP networks. And so you see 2 for the third octet, 3 for the third octet on the other interface. This means 2 logical layer 3 networks. Demanding that we cannot work with the classful system, we have to redefine the network portion as /24 in this case. By extending the network portion into the third octet and completely through the third octet, we now have the ability to take 172.16 and create 256 subnets out of one. We can take and simply count. Think about it. 172.16.0 through .255, all of which are usable, and that gives you a lot of subnetworks to play around with. So if you needed to add extra networks onto this router, you would be able to do so.